see Lindelof videos graphing a sine curve, and this one is red. Graphing y is equal to a sine of, this is actually omega, actually should look like that, omega x, and this is a pretty easy example. I just want to do the most, call it the parent function, which is y equals sine of x. So amplitude is kind of its height as a very, very loose descriptor of it, and it's its height from the horizontal line of symmetry. So just look at this for a second. We say that a, this a right here, is equal to amplitude, and that is equal to the absolute value of a. In this case, here we only have 1, so there's 1 in front of it, so we have absolute value of 1. So it has an amplitude of 1. Then we want to know the period. The period of a curve, of a trig curve, describes one cycle of the curve. So this is one cycle of that. And the way you would find that in general is to take 2 pi divided by omega. In our specific case, we have 2 pi. And here we can see that omega, this is right, this is x inside here, that there is an invisible 1 here. So there's 1. So omega is 1, which just gives us 2 pi. This one is actually really, really easy to do, I hope. So I'm hoping for that. Let's graph this, and let me show you how I graph it. I think this is really what you want to see. So let's just draw in our Cartesian plane. So here's our Cartesian plane. I'm just going to draw one cycle, and we know that this thing occurs, each period is in 1 pi. So this is what I'm going to start off by doing. I know in general what the sine curve looks like, right? It looks like this, doesn't it? It goes like this, like this. And I'm pretending that's as symmetrical as possible. Remember, this thing goes on and on and on forever out here, and it went on and on forever back there. I'm just looking at this one specific place. So what I'm going to do is this. I'm going to do this. I'm going to start finding some landmarks here. Like this is a landmark, this is a landmark, this is a landmark, this is a landmark. Where the curve passes through the horizontal line of symmetry, those are landmarks, and any extreme values can be landmarks. So this is what I want to make sure you get. When we graph a sine curve, we graph the angle, comma, sine of that angle. Because some of your teachers have taught you, and they're right, but then it gets to confusion. They teach you this. We go over through the unit circle, and they're like, okay, this is cosine theta, sine theta. And they're right, but when we're graphing the sine curve, we're not going to use any of the cosine part. We're going to use the angular value first. So this is how I'm going to do that. This is the angular value 0. So what I'm going to do is I'm going to go to my unit circle. I'm going to go to my unit circle. So here's the angular value 0. And sine of that value is 0. So the first 0 is from here. The second 0 is from here. And that gives us the point 0, 0. Now I know this extreme value. This is pi halves. So pi halves. Check out how I'm going to do this. I'm going to go to my unit circle. I'm going to find pi halves. So here's my pi halves. That's the x value, right? The y value is its sine value. So the pi halves that you just saw was this one. And the 1 you saw is this one. So pi halves 1. I continue around my unit circle. I get to pi 0. Let's look at that. Pi 0. I went to the angular value pi. Its sine value is 0, which on the sine curve gives me the point pi 0. Now I'm going to go to 3 pi halves, negative 1. And you can see same thing again. How do we do that? Well, that sucks, doesn't it? This thing is in the way. That's all right. 3 pi halves 0. This is 3 pi halves down here, and its sine value is negative 1. So that's where this came from. And then, of course, we have the angular value 2 pi, and its height is 0. So in this case, it's really, really easy. What I would do first, again, is draw the curve and then start labeling it. I'm going to do another example next, which is a little bit different. And what I'm going to do is I'm going to change this omega value right here. So I'm going to do another video right this second, and I'm going to change the omega value and see what that does. All right? All right, you guys, thanks for watching. If you haven't already subscribed, please do. Appreciate it.